When humans first stepped onto the moon in 1969, the world watched in awe. For the first time in history, life from Earth had reached another world. The astronauts of Apollo 11 planted a flag, collected samples, and returned home. But what they left behind was more than footprints. They left a question that still echoes today. Can humanity one day live there permanently? After more than 50 years, that question is being answered. NASA is preparing to return to the moon, not for a visit, but to stay. The plan is bold, ambitious, and deeply symbolic. Humanity's next giant leap is to build a base on the moon. Why go back? The moon is more than a dusty relic of space history. It is a gateway to the future. Earth's closest neighbor holds clues about the origins of our solar system. It is a testing ground for technologies that will take us to Mars and beyond. And it is a reminder that exploration is part of what makes us human. NASA's new era of lunar exploration is called Artemis. The name honors the twin sister of Apollo, the ancient goddess of the moon. While Apollo was about reaching the moon, Artemis is about building a sustainable presence there. Under Artemis, NASA plans to land the first woman and the next man on the lunar surface. But this time, astronauts will not only collect rocks, they will construct habitats, test life support systems, and prepare the moon to become humanity's second home. Reaching that goal requires new technology and international cooperation. NASA is not alone. The European Space Agency, the Japan Aerospace Exploration Agency, the Canadian Space Agency, and commercial partners like SpaceX and Blue Origin are all part of this global mission. Before anyone can live on the moon, we must first understand it better. Unlike Earth, the moon has no atmosphere, no protection from radiation, and extreme temperature swings. During the lunar day, the surface can heat up to 120 degrees Celsius. At night, it can drop below -100. Any lunar base must survive both fiery heat and deadly cold. The moon's surface, called the regolith, is a fine dust of crushed rock that can cling to everything and damage machinery. But it may also be a resource. Scientists believe lunar soil could be used to make building materials. Using local materials, rather than bringing everything from Earth, is essential for sustainability. The first step toward building a base begins in orbit. NASA is constructing a small space station called the Lunar Gateway. It will orbit the moon and serve as a staging post for missions to the surface. Astronauts will travel from Earth to the Gateway aboard the Orion spacecraft. From there, landers will ferry crews and cargo to the moon. The Gateway will allow continuous operations, even when conditions on the lunar surface are too harsh. It will also test systems for long-duration spaceflight, a crucial step toward Mars. On the moon itself, NASA has identified the South Pole as the prime location for exploration and settlement. Unlike the equatorial regions visited by Apollo, the South Pole contains permanently shadowed craters that may hold frozen water. This water is the key to everything. It can be turned into drinking water, oxygen for breathing, and hydrogen for rocket fuel. In other words, it can support both life and future missions deeper into space. Extracting that water will be one of the first major challenges. NASA's Volatiles Investigating Polar Exploration rover, known as Viper, is scheduled to explore these craters. It will drill into the lunar soil, map ice deposits, and test how to harvest them. The Artemis Base Camp will be the foundation for human life on the moon. It will include habitats for sleeping and working, a rover for transportation, and power systems to generate electricity. These habitats may be inflatable or built using 3D printing technology that mixes lunar soil with special binding agents to form strong structures. Radiation is one of the most dangerous obstacles. The moon has no magnetic field or thick atmosphere to block cosmic rays. To survive, habitats may need to be buried beneath layers of lunar soil or shielded with materials like polyethylene and aluminum. Power will come mainly from solar energy. Because sunlight at the poles can last for weeks, solar panels placed on high ridges could supply continuous electricity. In shadowed regions, nuclear batteries may provide backup power. communication will rely on satellites orbiting both the Moon and Earth, ensuring constant contact. This network will also support robots, rovers, and future missions. As the base expands, scientists will conduct research impossible on Earth. They will study how low gravity affects biology, test new materials, and observe the universe from a sky free of atmosphere and pollution. Telescopes on the far side of the Moon could capture radio signals undetectable on Earth, opening new windows into cosmic history. Building a base on the Moon is not only about technology, it is about human endurance. Astronauts will live in confined spaces, far from home, with limited supplies. Every action must be precise. Every mistake could be fatal. Psychological challenges will be immense. Crews will face isolation, monotony, and delayed communication with Earth. To maintain morale, NASA is developing new methods of virtual communication, entertainment, and mental health support. Life on the Moon will require teamwork and resilience. The people who go will not only be scientists or pilots, they will be mechanics, engineers, and explorers, united by purpose. As we plan for a permanent presence, new questions arise. Who owns the Moon? The Outer Space Treaty of 1967 declares that no nation can claim it. But commercial companies plan to mine lunar resources. The challenge is to create laws that ensure cooperation rather than conflict. International collaboration is becoming the backbone of space exploration. The Artemis Accords, signed by dozens of nations, outline principles for peaceful use and transparency in lunar activities. It is a vision of shared discovery rather than competition. Technology is advancing rapidly. Robots and rovers will prepare the ground before humans arrive. Autonomous construction systems could build habitats while astronauts remain in orbit. 3D printers could use lunar soil to produce landing pads and walls, eliminating the need for heavy cargo. One of the most promising ideas is in situ resource utilization, the practice of using what is already there. The Moon's regolith can be processed into oxygen and metals. Ice can be melted into water. Even sunlight can be captured to make fuel. This approach transforms the Moon into a self-sustaining world. In the near future, missions will test these systems step by step. Artemis 1 has already proven the Orion spacecraft and its launch system. Artemis 2 will send astronauts around the Moon. Artemis 3 will land humans on the surface for the first time since Apollo. Later missions will deliver habitats, power systems, and rovers to build the foundation of a lunar base. Each mission builds upon the last, laying the groundwork for a future where humans may live and work beyond Earth. The Moon is not the end goal. It is the beginning. Once we learn to survive and thrive there, we can apply those lessons to Mars. The Moon will become a launch point for deeper space exploration. Imagine a future where rockets refuel on the Moon, where telescopes gaze from its far side, where families on Earth look up and know that humans are living in that distant light in the sky. The idea that began with Apollo will become a permanent chapter in the human story. Every new discovery brings us closer to understanding our place in the cosmos. The Moon, once a symbol of mystery, is becoming a symbol of hope. Humanity's return to the Moon is more than a mission of science. It is a statement of vision. It tells us that our journey does not end on Earth. It continues outward, driven by curiosity, courage, and the desire to explore. When the first settlers step onto the lunar surface and look up at the blue planet hanging above, they will see the world that gave them life. And perhaps they will feel what the Apollo astronauts once felt, the fragile beauty of home and the infinite promise of the stars. The Moon base will not only mark our physical presence beyond Earth, it will mark a turning point in history, when humanity becomes a spacefaring civilization. This is the next giant leap. This is how NASA plans to build a base on the Moon. When humans finally establish a base on the Moon, life will unfold in a rhythm unlike anything on Earth. A lunar day lasts about 29.5 Earth days, 2 weeks of sunlight followed by 2 weeks of darkness. Astronauts and settlers will live in this extreme cycle, managing light, temperature, and energy with precision. Every sunrise and sunset on the moon will be a rare event, filled with brilliance and shadow. Inside the base, time will be measured by mission clocks and Earth communication schedules rather than sunrise or sunset. Life will be highly structured. Astronauts will follow carefully timed routines. They will wake, exercise, eat, conduct experiments, repair equipment, and send data to mission control. But beyond the routines, every small act will be historic. Every breath, every meal, every scientific discovery will represent a new chapter in human life beyond Earth. Food will be precious. Shipping supplies from Earth cost thousands of US dollars per kilogram. That is why scientists are designing systems to grow crops inside pressurized greenhouses. Experiments have already proven that plants like lettuce, potatoes, and wheat can grow in simulated lunar soil when enriched with nutrients. Hydroponic systems, using water and light instead of soil, could sustain future colonies. In time, settlers may harvest their own fruits and vegetables, creating a small ecosystem under artificial sunlight. Water, oxygen, and waste will be recycled in closed-loop systems. Nothing can be wasted. Every drop of water will pass through purification filters. Every breath of air will be regenerated. In this environment, technology will function as both the lungs and the heart of the colony. Outside the habitats, the landscape will be silent and endless. The sky will always be black, even during daytime, because the moon has no atmosphere to scatter light. The Earth will hang above the horizon, a blue and white marble, never rising or setting, but fixed in the sky. For settlers, that view will be both beautiful and haunting, a constant reminder of home. Transportation across the surface will rely on pressurized rovers. These vehicles will travel over dust plains and crater rims, carrying crews to scientific sites and construction zones. Some will be remotely operated, others autonomous, exploring regions too dangerous for humans. Energy for these rovers will come from solar arrays and rechargeable batteries. Future versions may even run on hydrogen produced from lunar water. Power is the lifeblood of any base. Solar energy is abundant but intermittent. During the long lunar night, batteries and small nuclear reactors will provide backup. NASA's Kilopower project is developing compact reactors capable of delivering reliable electricity for years. These systems will keep habitats warm, lights on, and communication active even when darkness covers the moon for weeks. Communication with Earth takes about 1.25 seconds each way. That small delay will change how teams work together. Astronauts will rely on more autonomy, making quick decisions without waiting for instructions. Artificial intelligence systems may assist them, monitoring equipment, predicting failures, and analyzing data faster than any human could. Safety will be constant priority. Micrometeorites can strike without warning, traveling faster than bullets. Airlocks and pressure suits will be double-sealed. Radiation monitors will track cosmic exposure. Emergency shelters will be located near every habitat, ready to protect crews during solar storms. Every design element, from door seals to helmets, will be engineered to preserve life in an environment that offers none. Science will flourish in this new frontier. The moon is an ideal laboratory for astronomy. Telescopes placed on its far side will be shielded from Earth's radio noise, allowing them to detect faint cosmic signals from the early universe. Lunar observatories could peer deeper into time than any telescope in orbit. Geologists will study rocks untouched for billions of years, revealing the early history of the solar system. Biologists will observe how life adapts to low gravity, paving the way for human survival on Mars. Mining the moon could become a cornerstone of space industry. The surface contains valuable elements like titanium, aluminum, and rare metals used in electronics. Even more intriguing is helium-3, a rare isotope that could one day power nuclear fusion reactors on Earth. Extracting resources responsibly will require strict regulation to prevent environmental damage and preserve the moon's scientific value. The goal is not exploitation, but sustainable development. Over time, the moon could develop an economy of its own. Private companies might operate transport services, energy grids, or research stations. Engineers could build robotic construction units. Lunar tourism might even emerge for the wealthy few willing to endure the long journey. The first settlers will be pioneers, but the second and third generations could become citizens of a growing lunar society. International cooperation will be vital. The United States will not be alone on the moon. Europe plans robotic missions. Japan is developing rovers. India and China have already landed spacecraft. In the future, lunar outposts could link into a global network of research and resource sharing. This cooperation may help prevent conflict and ensure the moon remains a place of peace, science, and discovery. If this journey inspired you, stay with us for more cinematic explorations into space, discovery, and the science that shapes our future. Subscribe, stay curious, and never stop looking up, because the story of humanity has only just begun.